this is going to help people considerably. Now, I'm not the only one to consider this specific idea because it's very similar to J. Marvin Herndon's whole Earth decompression dynamics, or WEDD, the WEDD model, as he says it. He's much more involved with establishment science than I am. Actually, he's basically in the establishment, and I'm just an outsider, but my outside contributions are very similar to his. But his has a heat source, being it's some kind of nuclear dynamo or something similar. Mine is just a continuation of star evolution itself. So there you go, there's two main differences between stellar metamorphosis and Herndon's whole Earth decompression dynamics. Not to mention, he doesn't include stars in his whole Earth decompression dynamics because he ignores earlier stages of star evolution, such as brown dwarfs, red dwarfs, and all the way up to the sun, and even hotter stars, such as blue giants, like Bellatrix and Pollux and things like that. But to start this off, to cut things really simple here, during a brown dwarf stage, you have core formed under very high pressure, which means the thick atmosphere is pushing down all this material as it forms what's called rocks and minerals. Yes, rocks and minerals are the end result of a star's evolution. Now, what you have here is the slow release of pressure as the core begins rebounding, because what happens is the atmosphere gets, it dissipates. All the material exits the star, and sometimes you even have an impact, which then scatters material, and in the star, that material maintains angular momentum and just comes up as rings. And we can see those rings in Saturn, Jupiter, Neptune, and Uranus, all those stars, very evolved stars. Now, what happens is after this rebounds in the center of the star, what happens is that it begins cooling faster, and then it starts contracting, creating folds in the interior of the star. Now, the majority of the atmosphere is dissipated and the rings are dissipated, but what happens is the Earth and the surface starts contracting, creating lots of folds, creating what are called fault lines, things like that. And we can see evidence for that inside of a lot of geological formations. If you pick up a basic field geology book, basically anywhere you turn, you'll see where it overviews what these folds look like. This is the book written by, what's his name? Leahy. But a lot of the folds look very different. A lot of them come at different angles. But anyways, you get the point. So the idea of plate tectonics is unnecessary. And eventually you get to the present day where you have still contracting as leftover heat escapes as volcanoes, geysers, lava, and as well as mechanical, which is manifested as earthquakes. Now there's two types of heat escape. You have mechanical, where the ground moves and shakes and readjusts as it contracts. And you have thermodynamic contraction, meaning material gets colder, and as solid material gets colder, it freezes and shrinks. And that's really basically, the Earth has a lot more shrinking to do, meaning earthquakes happen as the star is in black dwarf stages, and the star continues cooling for many millions of years. But basically, there you go. This is the end of a star's evolution. Now, it's very generalized because obviously you had a lot of other types of things in there, like chemical reactions, exothermic reactions, redox reactions happening. But basically, if you can actually reverse engineer stars like Saturn or brown dwarfs all the way to where they're going to eventually be with like Earth, and obviously after Earth they go all the way down to Mercury, you know, Venus, and stars that have all the way lost all of their heat and are just floating dead balls wandering our space. All right, today is June 27th, 2015. Hopefully that helps.